Right. So one of the things that I wanted to talk about as we start to introduce this is, once again, you're looking at the model y is equal to a times b to the x. And depending on whether b is absolute value of b is less than 1 or greater than 1 will determine whether you're dealing with growth or decay. So here was what our growth model looked like. Okay, our growth model looked like this sketch. Okay. Now, one of the ways that, or the model, one of the ways that you can model this, or the transformation that we have yet to talk about, is a reflection that occurs inside our function. If there's a negative inside your function, meaning it's directly applied to the x, it's not outside the x or outside the function. If there's a reflection inside the function, that reflection is a horizontal reflection, which means it's across the y-axis. And remember, if there's a negative, if a is a negative value, the reflection is outside the function, so it's a vertical reflection. It gets reflected across that asymptote or across the x-axis. But if there's a negative inside our function, so if it applies directly to our x, the reflection is going to be sideways. It's horizontal, left to right. And so if we took this function right here and we looked at the graph y equals a to the b, a times b to the minus x. And the way that this would appear with respect to this reference graph here is it would reflect it across the y-axis. So this portion that goes up and to the right would go up and to the left, and this portion that goes down and approaches the asymptote here goes down in this way. So this right here is the parent function for decay. And so notice you could also say, again, the equation here is y is equal to a b to the x, where absolute value of b is less than 1, right? It can be any form. It doesn't have to have it, but this is why, or this is what you can identify. The reflection, the negative inside your function is going to cause horizontal reflection, which makes this graph down here. Now, with all of that said, you don't even need to worry about this because I would suggest your first step be if you identify a negative in the power, just flip your base and change it to a positive. That way all the rules that we've already talked about will be the ones that apply. Okay. So let's talk about just kind of the generic properties of this parent function. Okay. In the parent function, so this blue graph is your decay function. So what is the domain of that? Are there any limits for the x and y values in that function? No. X can be any number from negative infinity all the way to positive infinity. So if you're identifying domain for a decay function, it's the exact same as it would have been for the growth function. And what about the range? Is there a limit to the y's? What's the lowest possible y value here? The lowest y value is 0. It never actually reaches that. It simply approaches it. And then the highest possible y value in this blue graph is, again, it extends infinitely up. So there's your domain and range. This is true for all the parent functions. The only time this would change is if there's a vertical reflection. If that happens, then the range becomes negative infinity to 2, 0. Okay, let's look at the left and right behavior. So if we look at this parent function, to the left, this blue graph, we go up and to the left, so it's up or it rises to the left. And to the right, it goes down, but again, it doesn't go down consistently. It goes down, but then gets smaller and smaller increments of going down. So it approaches the asymptote. Okay, which brings us to where is the asymptote? Okay, so we're dealing with a horizontal asymptote again, just like we did with the growth function. So our equation for that is going to be y equals 0 is our generic one. So here, the built-in asymptote for that parent function is y equals 0. But do note that this is going to adjust with any vertical shifting that occurs. Okay, so if there's anything added or subtracted on the outside of the function, the horizontal asymptote is just y equals whatever that shift is. Okay. Now, just like with the other graphs that we dealt with, there can be horizontal shifting that occurs if there's something added or subtracted on the inside of our function up in the power. There can be vertical transformations or vertical shifting if there's something added or subtracted outside the function. If a happens to be a negative number, then it reflects across that y, or the horizontal asymptote, so it's a vertical reflection across the x-axis. And so even though I talked about the horizontal reflection here, the same rules still apply for the vertical reflection. So everything is exactly the same as the graphing in the section 7.1.